In the last episode, we've seen how frustrating Homebridge can be with all its different plugins. This is why today I'm going to show you a different method of controlling your Arduino, where we will ditch the Homebridge server completely and instead we will set up the Arduino to be its own server that will communicate with the Apple devices using the HomeKit Accessory Protocol, or HAP for short. We are able to do this only because of the tremendous effort of Mi Chow Chow, who created an Arduino library that takes care of all the behind-the-scenes jargon of the HAP. However, we still need to set up the accessories that we will be using, and that's why we need to refer to the Apple HAP documentation. You can download the free non-commercial version using the link in the description below. As always, our aim for this project is to control a LED while reading the temperature and humidity from a DHT11 sensor. In order to run the project, you will first need to download the HomeKit ESP8266 library by Mi Chow Chow in the Arduino Library Manager. Then, download my modified Arduino sketch using the link in the description below. Don't worry if you don't really understand it now, we will dive deeper in the code later. In the Wi-Fi info header file, modify the SSID, which is the name of your Wi-Fi network, and the password. Then, make sure that you have selected the correct board and port from the Tools menu and hit the Upload button. Now, make sure that your Apple device is connected to the same Wi-Fi as your Arduino and open the Home app. Add a new accessory and choose I don't have a code or cannot scan option. Your Apple device will scan the network to find your Arduino. Once it does, it will request a password. Simply write 8 ones. Now, this simply, you should be able to control your Arduino from the Home app, or even using Siri voice commands. Turn the LED on.
Okay, the LED light is on.
Turn the LED off.
Okay, the LED light is off.
What is the temperature in the room?
It's 21 degrees Celsius.
What is the humidity in the room?
Humidity in the bedroom is high at 77%.
As you can see, it is much faster and easier than using the Homebridge method. Now, let's dive deeper into the Arduino code and understand how it works. First, we can see that there are 3 main tabs. The first being the main Arduino sketch, the second a C file in which we can add new accessories, and the last is the Wi-Fi info, which is responsible of connecting the Arduino to the internet. To understand the main sketch, we need to first understand the accessory.c file. So scroll to the bottom of the accessory.c file where you can spot the section where we add new accessories. For this project, I created 2 accessories with distinct ID numbers. In the Apple HAP protocol, an accessory is just like an empty container, which needs to be filled with services to do useful stuff. Services can be a temperature or humidity sensor, a light bulb, a fan, and much more. You can see the list of all the supported services in section 8 of the HAP documentation. Also, every service has a set of characteristics, some of which are required while others are optional. For example, the temperature sensor found in section 8.41 of the HAP documentation has 6 characteristics, from which only the current temperature is the required characteristic. Also, we can notice in our accessory.c file that every accessory starts with the accessory information service, which is needed so that HomeKit can identify our accessory, and without it, it just wouldn't work. You can read more about that in section 8.1 of the HAP documentation. For this project, I will include in the first accessory the temperature and humidity services, along with the required characteristics and the optional name characteristic. We can notice that the current temperature and humidity characteristics are written in a different format than the rest of the characteristics. And that is because these are pointers, which point to the temperature and humidity characteristics that I created just before the accessory section. I had to create them this way so that I could pass them to the main Arduino sketch to update their values regularly with the readings from the DHT11 sensor. For accessory 2, I had to include, in addition to the accessory information service, the light bulb service so that I could control my LED. Here we can notice in the brightness and on characteristics that we have something called getter and setter. These are functions responsible of getting or fetching some data and setting or sending some data to the Arduino. And we can see the details of those functions above the accessory configuration section. These are quite basic functions, so I won't be covering them in details. But if there's something you didn't understand about them, let me know in the comment section and I will definitely explain it to you. In addition to the setter and getter functions, there's a bunch of additional functions. First, there's the accessory initialization function, which sets the pin of the LED to be an output. There's also the LED update function that converts the value of the brightness sent from the Apple devices to a PWM signal, and the accessory identify function, which, as stated in section 6.7.6 of the HAP documentation, is a must and implements an identification routine for your accessories. Finally, beneath the accessory configuration section, there is the server configuration function, where you can change the password of your accessory from 8 ones to any 8-digit password you like. Now, let's move to the main Arduino sketch. First, we need to add the sensor libraries. Note that you can only add them in the main sketch of the Arduino, which is a CPP or ENO file, and not in a C file, such as the accessory.c file. After defining the DHT sensor variables, we need to add the variables that we want to pass from the accessory.c file. To do so, use the following syntax. Write extern_c before the type and name of your variable. For this project, we need from the accessory.c file to update the current temperature and humidity, the server configuration, and the accessory initialization function. Now in the void setup, initialize the DHT sensor, connect to the Wi-Fi, and initialize the HomeKit server by using the myHomeKit setup function. In the void loop, we simply need to run the HomeKit loop function, which will report the values of the sensors every 10 seconds using the HomeKit report function. Now, you should be able to control the Arduino using the HomeKit app or Siri voice commands. I tried to make the explanation as brief as possible without skipping any important section. But if there's still something you did not really understand, let me know in the comment section below. You might also be helping out someone with the same problem. Now we are able to control our Arduino using the HomeKit app and Siri. And the next step in the Smart Room project is to connect the Arduino to the appliances in my room. This is why next week I'll show you how to prepare for such a transition, because you want the transition to be as fast as possible. The last thing you want is to find yourself missing something after that you have removed all your connections. I don't think you will really enjoy spending the night in the dark and without any heating. So if you don't want to miss this episode, make sure to subscribe. In the meantime, you should probably watch one of the videos on the screen right now and like the video if you found it useful. And I'll see you next week.